The main problem in the maintenance industry is it has a lots of pages where everything is unstructured format, and if we want to use any AI or any traditional programming languages, we need to be very careful because even a small mistake in the machine costs up a very large amount for the team. So now the problem is how we can evaluate AI such that for every user question there should be 100% validation result. So that is the main goal for me, to use the AI in a safety manner where for every question we get 100% validation source as a proof. And we can see that according to the survey we have 1000 plus pages even for a single manual, and takes 30% time for searching the document, and it costs a more $100 million to maintain the manual maintenance. And the reason, if anybody wants to hire the engineer, definitely he or she should know everything about the maintenance thoroughly, then only they can solve the problem if anything occurred into the system. And also the problem with the traditional search is it takes time for the manual lookup, and also there is no visual content if it is not available in the system, and it's a very slow verification process. But if you transform the entire traditional search into the pure LLM search, the another problem is that it's hallucination risk, because we don't know whether the answer is correct or not. Every time we need to check whether the answer is existed or not, and also there is no trust from the LLM side. And if you think in a RAG direction, we can get some answers to some extent, but the problem with the RAG is we have more unstructured document where the chunking takes more time, and we don't know how, I mean, when the answer is scattered around multiple pages or multiple volumes, so it takes so much of time. So that is the thing. There is a solution which is proposed with a Colpal team. It's a Colpal engine where they the main goal of this algorithm is to trying to divide every page into some small patches using a vision encoder, and applying the linear projection, then again using the large language model encoder to maintain a subset of high dimensional space in a way such that even the text, audio, video, and any type of data structure should be there in the high dimensional data, which is helpful for us to see in multiple directions. Now this is the training part, and coming to the testing part, the user will ask a question. Every question the LLM encoder try to get the tokens. Now the trick is, for every token it will check what are the associate patches are there available with high score. Once it get checked with all the pages with all the patches, then what it will do is, now it will the system needs to rank the pages in such a way such that the page 1 is very most important when compared to the page 2. And also the another important thing is, as I mentioned in the manuals there is a step by step process. Most of the engineering manuals contains a step by step process. For example, from the screen you can see these are the step by step process, right? So that is the another issue with this, that I mean, we need to consider a large amount of pages sometimes if the answer is scattered around the volumes. Now this is from the inference side. User will ask a question, it will try to get the top pages, now top pages from the system, then the top 5 pages are converted into the base 64 format along with the user query, which is sent to the Gemini Flash, which is advanced visual language model. Then the system try to get the answer from the passed context, and we are directly passing the top relevant patches to the user. And the reason for checking from the Gemini is, sometimes if the answer is not captured from the large language model, even we have the proof in the top relevant patches. So that is the thing. And also in the inference it only take 30 milliseconds per query, and there is a lot of content I mentioned here how the system works with a simple example. I mean, it is not the right time to explain everything, so let us quickly jump into the demo. Yeah, this is the front page of the application where the users can see the attached volume. Here I used a sample volume of Boeing airplane. The number of the airplane is 737-800. It contains around 86 pages. Now I prepared some questions. These are not fixed questions, these are some questions which I prepared. The question I asked is, describe the correct sequence for retracting the flaps and speed breakers after landing? This is the question, and you can see I provided two answers. One is a multimodal RAG answer, another is a text based answer. In the multimodal RAG answer, first you can see that it will try to get the relevant documents using the Kolpali engine, and it will try pass the top 5. I mean, here I use the Windows as the top 5. It will now, these are sent to the Gemini model, a vision language model, for getting a final answer. Here you can see that the order is, first they need to flaps, the flap should be retracted, then the speed brake should be retracted, then the wing or landing lights are off, and so we need to check whether this is there in the attached volume or not. So we need to show something to the user that yeah, the answer is correct and it is associated in some pages in the document. And you can see that according to the top relevant page, it has a similarity score 19, where it exactly contains the order. We asked that what are the steps are required after landing, and these are the things which we get back, that flaps retract, speed brakes retracted, and wing retracted. I am not only presenting the top one, but I am also presenting top 5, because there is a chance that the information gets scattered around the pages. But here, yeah, the information is there in a single page, but sometimes there is information will be there in more than 2 or 3 pages. So that is the reason I have printed everything. When compared to the text track, in the text track you can see that it given that speed brakes, we need to apply the speed brakes and we need to apply the flaps. But you can see that the answer is not complete yet, because it depends on the how we are doing the chunking and all the things. And also we don't have any proof whether the answer is correct or not, because in this example definitely the pilot should follow the same steps to do after the plane get landed, right? So the steps are very important, and any mistake cost a loss of crores of rupees to the airline industry. So that is the reason, by leveraging the Kolpali with the Gemini, we can create a system with 100% validation as a proof. Let us check with another question. Now the question is, what light should be turned on during taxi and takeoff? Yeah, we got some answer from multimodal, right? And they mentioned that the provided illuminate something, the light should be switched to test. However, it does not specify light should be on during the taxi or takeoff. And you can also see these are some important images for the question. If I open the question, you can see something is mentioned that large circuit frequently equipped in the steering to tilter something. And you can see here we asked something about this thing, how we need to turn off the light after in the taxi mode. And these are some relevant images. In the text track, we get that landing lights, taxi lights, wing lights, etc. So for this question we got something, and here we get the source information as a back to check whether the answer is correct or not. Now we will ask another question. Another question is, how do I interpret all the information shown on the engine indicator and crew alerting system ECIAS? And the answer from the multimodal RAG is something else. Yeah, not this, yeah, sorry. Yeah. So first we need to do N2, then FF, then oil press, then oil temperature, oil quantity, VIB, and this is the thing. And you can see that something is there here, that engine indication and crew alerting system display, and these are the steps, and these are the required steps the pilot need to done according to this question. If you check from the text based RAG, yeah, we get something that upper EICS display and lower EICS display. In the lower EICS display we mention N2 oil pace, etc., but they also mention upper EIS display. In the question we didn't mention explicitly that whether it should be upper or lower, and these are the some of the problems with the multimodal, like when the question is, I mean, it's purely based on how the images are get patched in the vision language model. For getting more advanced answers, there is an option called fine tuning. We need to fine tune the model with some set of questions and answers to along particular to this domain PDF, which will give more answers if the information needs a very granular information. So this is the thing. Yeah, thank you for one and all.